Hello and welcome back to the Coder's Legacy channel. In today's video, we're going to explore the concept of blitting in Matplotlib. Blitting is a very powerful and useful concept that's used to improve the performance of our Matplotlib graphs when drawing them to the canvas. Blitting is a rather advanced topic and a bit comprehensive, so be sure to pay attention. We're going to go into it in quite depth and explain every single function and concept being used. We'll show you several examples. I'll show you performance benchmarks as well, with blitting, without blitting, and we'll observe just how much of a benefit we got. So first up, what is blitting? Well, blitting is the technique of only updating on the screen what is required. To understand this, you need to understand how drawing on a canvas works. When you draw a graph, and then maybe you want to update that graph, like you draw a scatter plot, and then you want to update that scatter plot and maybe add in a few more plots. You want to add in a few more dots, or you have a line graph, and you want to change something a bit in there. Now the thing is, when you're doing normal drawing, okay, what you've been doing up till now, basically, then the entire canvas is basically removed, okay? Like it's refreshed. The entire thing, everything is drawn again from scratch. Blitting is the concept of only redrawing what has been changed. For example, let's say that we have a scatter plot with 100 dots, 100 plots, okay? Now, let's say we want to add in 10 more. Now, you add them one by one, okay? Now, every time you add one of those, the entire plot is going to be redrawn from scratch. So you're basically plotting everything all over again. Now, that's kind of dumb, right? In a sense. It's very simple. It's a very simple logic. Just remove everything and then redraw. But it's also a bit slow and inefficient. And you won't notice it normally, maybe, but in intensive applications where you're maybe doing a lot of redrawing and stuff, you will notice this change. Trust me, I have noticed it myself in a very graphing intensive application. Okay, and it is noticeable. So what you want to do ideally is implement a blitting. So when we want to add in 10 more plots, 10 more dots into our scatter plot, only those dots will be drawn to the screen. Okay, the other 100 which remain constant will remain constant. They will remain as they are. They will not be redrawn. Okay, that is the concept of splitting. Okay, and now that you understand that, hopefully, let's begin this video. Now, the first thing we'll do is explain the scenario. And as I described earlier, we're basically working with a scatterplot scenario. I'm going to start with the code of mine that does not have blitting. Okay, this one. And let me show you this first, then I'll show you the blitting version. All right, so we have an empty x and y array, which is our x and y data. And then we plot it. It's empty right now. And then we define the axes, and then we show it. We show it initially. Block is equal to false basically shows the graph, but it doesn't block it. If you're familiar with plt.show, it's basically gonna block your code. It won't proceed past that point until the window has been closed. Okay, the blocking one that I want to add is over here, plt.show. Okay, this is the blocking version. That's going to stop it at the end to prevent our window from closing until we manually close it. All right, then over here, what this is doing over here, I will explain later. Then this is some benchmarking code from last time that we'll talk about later. And then over here is where I iterate over 100 times, generate some random data, one random data, okay, in each iteration. In each of one of these 100 iterations, we generate one random data for x, one for y, update the data, okay, but we don't draw it yet, okay, and then we draw it, and then we flush events. I'm not, oh yeah, okay, this is important to put to basically ensure that the changes get redrawn. This will redraw it, but this ensures that it is redrawn by basically there's a queue system involved in Matplotlib, and every time you call draw, then it puts it in the queue. This ensures that the queue gets flushed completely, like we actually do everything that is in the queue. Okay, so that's this code explained. All right, and if I run this, we can just see what happens. Okay, fairly normal. And this took 5.3 seconds basically. And now let me go over to my blitting code. Now this is an import I made from a different file. I'm gonna have to explain this file first, the BlitManager file. This is basically an approach recommended by the documentation in Matplotlib. If you make this BlitManager class just one time, then you're set completely. You can reuse this class, and I'll make this class available to you, by the way. I'll leave a download link, a website link to my website, and you can access this class from here. And you can easily, within 2 or 3 lines, you can implement blitting in your own application. But you should still understand how this code works, and that's what this video is about. I'll explain how you can add blitting, and if you want to customize anything inside this class, you can go ahead and do so. Okay, most of this is from the Matplotlib documentation, by the way. Okay, so this is a BlitManager class, and basically it's a generic solution, a manager that we've created that is going to help us do the blitting. Okay, we just call the functions, like in this file of mine, we're just calling the functions, update functions, and we're just passing in the scatter object to it, which is returned from here. That's all I'm doing, and the blitting has been implemented here. It's just that easy. Okay, so let's explain this. What we pass into this BlitManager class is the canvas, the Matplotlib canvas. And let me show you what that is. Okay, the figure object that you create using plt.subplots or plt.figure, whatever, every figure has a canvas object. So we pass that over here, and then we pass in the artists. In Matplotlib, an artist refers to something that is drawn, an object that is drawn, like a bar graph, like a scatter plot, or well, really anything, pretty much. Anything that is drawn to the screen. Okay, so next we just store this in self.canvas, initialize this artist's array to 0, and self.bg, well, that stands for background. We'll talk about that in a minute. And over here, what happens is that we iterate through all of the artists that were passed in here, and then call this function. And it looks a bit fancy, but it's actually not. We could have just assigned this directly over here, but I'll show you why we used this function. Let me come down to this function. Basically, the reason why I like this class, this is actually again from the documentation, but it implements a lot of validation, a lot of error handling, and if we actually removed all the error handling, this class would only be like 20 lines. But there's so much error handling in here that, it's pretty good. This here, for example, is just error handling. It checks to make sure that the figure that the artist belongs to is the same as the figure of the canvas object that we passed in. Okay, and if not, it's going to raise an error. This over here sets the animated value of our artist object to true. This is not very important. It just makes sure that the artist is not drawn to the screen until we call the draw artist. Where is it? There. Until we call the draw artist function. Okay, that's it. It's not really a big deal. Then over here, we append it to the artists list that we initialized over here. Okay, and then we connect our canvas, okay, the canvas we passed in over here, to the onDraw function. And this is connected to the draw event. The draw event triggers whenever we draw something to the canvas. And what is this function, self.onDraw? Again, this is error handling. It checks to make sure that the event is not null, and if it's not, it's going to check whether the event occurred on that canvas on the canvas which we passed in over here. Okay, so the draw event should have occurred on the canvas that we passed in to our BlitManager class. Okay, again, just error handling. This line right here is extremely crucial, and to better understand this and a few other blitting concepts, I'm going to pause right here, kind of, and we'll go over to Paint right now, over here, and discuss exactly how this works. I want to do some drawing over here to help you guys understand what's going on. So let's assume that we have this graph, okay, and it has a bunch of circles, okay, and let's draw another graph. this represents our new state, the state we want to move our graph to. Okay, or actually, let's not do that. Let's just copy this. All right, this is the state we're currently on, this one over here, and this is the state that we want to move to. Let's just say we want to move this up here. Okay, that is the change that we want to make. So in with regards to this, this is the artist that we want to change, and these are the artists that remain static. So up till now, we've at least established that in Blitting, these two artists would not be redrawn, right? Only this artist is going to be redrawn. But this is the theory. How does it work, right? That's a good question. So we should understand that. To summarize, without going into extreme details, what happens is that we store a copy of the current state of the graph before we make any changes. So basically, we have a backup. We have the old state. So this new change is made internally. It's not drawn to the canvas yet. It's just made internally. The changes are made internally. And we still have this old copy. So something like this. Old copy, also commonly referred to as the background. And this is the new state. Okay, then the blit function, when we call it, it observes to see what has changed. It's going to compare these two graphs and then see what locations have changed. And it determines this because these images are basically stored as pixel arrays, RGBA buffers. And it just compares the pixels. It compares to see which pixels have changed. And then it redraws those pixels and only those pixels. So, for example, what it does is takes this. Let me just make that a bit smaller. And it compares these two, and it finds two locations that have changed. These two. And let me just color them a bit differently with green. So it finds that these two locations, let me color that too. Because, yeah, it finds that these two locations have changed. So everything else other than the green spots, they remain constant while the green spots get redrawn. And this spot is also needs to be redrawn because you need to erase the old position as well, right? You need to update it with white. And this location you need to update with red. So these are two locations which are redrawn, and everything else remains constant, these two objects. So that they don't need to be redrawn, which again is the benefit of splitting, okay? So that's basically the concept. Now, if I come back here, we can observe that this is actually what's happening over here. We're storing the background before we make any changes. Okay, now you understand that, hopefully. Okay, this is the copy that we're going to use. And in the update function, we're using this copy. What we do is restore this copy. Okay, like a change is made. Okay, the change was made. This is the new state now, but we have the old copy with us, stored in self._bg, right? So what we do is restore that region and then draw the updated changes and then use the blit function. And this is basically, after this is the blit function's responsibility. It handles everything from there. Which spots, which pixels need to be rechanged and which ones do not. And then we update the changes by flushing all the events in the event queue. Okay, that is the magic of blitting, and I think it's been like 15 minutes, and we've finally completed the theory. So after all that, we're finally gonna run the blitting code. And just to show you again what's going on over here, we import the BlitManager, okay? And then we pass in the canvas. We pass in the scatter object, which is our artist, right? And then over here, we iterate 100 times, generate a random x and y coordinate, add that to our scatter function. And this, by the way, is just a fancy way of concatenating the arrays. It's a NumPy function. All right, and then we call the bm.update function. Bm is our BlitManager object. That is it. I'll leave a link to my website. You can just go there, and the code for the BlitManager will be available over there. Okay, and yeah, let's run this code. And if you remember the time for the old one without blitting, that was 5.3 seconds. This is 2.6. That's a 2 times improvement, which is a really big deal, honestly. And this can maybe be expected to even get better, maybe, if we have more artists. The more artists you have, the more this performance difference will increase. Like imagine you have 10,000 artists and only one needs to be changed. So obviously the performance difference is going to be much greater over there than it is right now. So this is a pretty small scale example, in my opinion. So yeah, hope you guys enjoyed the video. Hope you guys understood blitting. If you want to see more content like this in the future, if you want to see more content on blitting, again, you can go ahead and request something if you want to, and I'll take a look at it. And if it's worth it, and if people are showing interest, then we can go ahead and make something on it. Okay, see you guys in the next video.